Hi and welcome to Prototype. We will be solving the problem for LeetCode 278, first bad version. This is another problem in the LeetCode 75 study plan. Let's get to it. You are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check. Since each version is developed based on the previous version, all the versions after a bad version are also bad. Suppose you have n versions, 1 through to n, and you want to find out the first bad one, which causes all the following ones to be bad. You are given an API, it returns a boolean, and it's called isBadVersion, and it takes the ith version, which returns whether version is bad. Implement a function to find the first bad version. You should minimize the number of calls to the API. Okay, they give an example where there are 5 versions, and the bad version is number 4. And they give this explanation where we call 3, and then is 3 bad? It is not. So then it wants us to call 5, and then we find that is true. However, we don't stop right away because we want to find the first bad version. Okay, so then it calls 4, and then it finds that that is also true. And we already know that 3, the left neighbor, is false. So 4 must be the first bad version. Okay. So as you could see in the example, they want to do a binary search. Obviously, if we're looking at this, the brute force or the most intuitive way would be to just use a linear solution for let I equal 1 and then go all the way through to n, and then you'll find the first bad version that way. However, that is obviously not the most efficient way. It wants us to do a binary search. Okay, so let's do that. We'll need a left pointer, and that'll just be initialized to 1. We can actually see in the constraint that the smallest number will be 1, and the largest number will actually be 2 to the power 31, so just small enough for a 32-bit integer, so we don't have to worry about 32-bit integer overflow if you're using a different language. And then we'll have a right pointer, let right equal to n. And we'll use a trusty while loop, so while left is less than right. We calculate the mid. The mid is, we can use math.floor, and it'll be left plus right divided by 2. And we're going to math.floor that, so imitating integer division. And we'll have a check, and that is mid a bad version? We'll do something, otherwise we'll do something else. Okay, what are we doing if we find a bad version? How much can we reduce the elements from 0 to n? Well, if we find a bad version, any bad version, we know that there could still be more bad versions to the left. We don't have to check the right, because if there are more versions to the right, we know that they're all bad, and we want to find the first bad version. So what does this mean? Well, we'll be moving our right pointer, and we actually want to move it to mid. We want to move it to mid because we're reducing the elements that we're searching up to mid. Specifically not mid minus 1, because we could find out that the mid is the first bad version, and we don't want to exclude that, right? So if we went mid minus 1, then if mid was the first bad version, then mid minus 1 would mean that it becomes the last good version. So we want just mid. And then in the other case, if it is a good version, then we're going to move our left pointer, and we're not going to move our left pointer to mid because we know that mid is a good version, so we can eliminate that. So it'll actually be mid plus 1. And this will just keep running until it turns out that left will equal to right. So actually we don't even need left is less than right. It'll be strictly left does not equal right, and then we can return, well, either right or left. Let's run it. And we can submit this. Okay, now let's it apparently beat 74.6%. Now let's think about this again. So let's think about a potential base case, and the potential base case where there's only two versions, and let's check the first version is bad. If the first version is bad in the n equal to case, well, left is 1, right is 2. Left plus right is 3, divided by 2 is 1.5. We floor that, so it's 1. So mid is 1. Is 1 a bad version? Let's say that the second is the bad version. Is 1 a bad version? No. Then left becomes 1 plus 1 is 2. If the first was the bad version, we're going to check one first. And then is 1 a bad version? It is. So our right pointer becomes 1. Okay? So we know that the base case resolves essentially because either the left is a good version, in which case we increment it by 1 to the right to the first bad version, or it's the bad version and then the right pointer will be assigned to the mid. Okay. A couple other things. So if you watch my other binary search video, there's a couple other ways to do this. We could just use a bitwise operator if you didn't want to use math.floor. And actually, let's just use the unsigned right shift. So left plus right, unsigned right shift by 1 digit, submit. That gets us the integer division, 95.7%. Okay, that is the solution to LeetCode 278 first bad version. Subscribe to see more. We'll be doing the rest of the LeetCode 75 study plan questions in short order. Thank you, and see you next time.